We're going to use that first set of data. Now the instructions say identify the relationship as linear, quadratic, or exponential. Also find the model that best fits the data and its R-squared value. We're going to use R if applicable. Okay, so we're going to go to Desmos here, and maybe if I can do it. I didn't have it open. All right, we are going to click the plus button up here in the left corner, and it gives us the option for an expression. That's what we normally put in there. We need a table, and we're going to type in the x values, so 170, 470, 90, 710, 510, 290, 950. Use all three tables there. Okay, and then we're going to go over here and put in the y values that go with that. Okay, now it is constructing a scatter plot as you're putting that data in. Now, I don't know about you, but I don't see any points. Let's think about y. We have these x values here that are ranging anywhere from 90 to 950. Well, our graph is not set on that right now, so we need to fix that. We need to go up to the wrench in the right-hand corner, and I always turn off the minor grid lines. I don't like those. They get on my nerves. For the x-axis, you need to change your x values. Our minimum x value is 90, so I would go just a little bit below that. Let's go with 50 for the minimum. And then our biggest x value was 950, so I'll go a little bit bigger than that. I'll go to 1,000. And I can see in the background right now that, okay, there's my scatter plot. There are my values. And if you want it to show up a little bit bigger, you can drag that table, or you can drag this over here on the side to give you some more room to see things. Okay, so just looking at the data, our choices are linear, quadratic, or exponential. Which one do y'all think that it is, just looking at the scatter plot there? Probably linear. So let's start with that model. Now, here's the good thing. When you type the y, you don't have to do the subscript. If you type a 1 after that, it automatically puts it as a subscript. So y1, it'll automatically put it as a subscript. The tilde is shift and the button beside the 1, and then mx1 plus b. And you see, as you start typing that in, it starts working it out, and then it graphs the line right there for you to see. So let's look at the statistics over here. Ignore the r-squared. Let's just look at r right now. It's negative 0.8694. So negative because of the negative correlation, the negative slope there. And I mean, that's pretty decent. It goes through the middle of our data, but it's not super tight. When you see the word residuals comes next and it has the option to plot, go ahead and click that. And then all of a sudden these data points show up around the x-axis. So I told you that that was the difference between the actual and the predicted. So let's look at this first data point, where it is in relation to the line. So it's below by about that much. Well, look at that. That's the difference right here. The next one is above the line by about the same amount. It's above the x-axis that much. These two, the next two data points, are a lot closer to our regression line, our model, and notice how close they are to the x-axis. This one's actually almost on top of the x-axis. And if you look back up at your table, it actually adds those residual values. So again, these numbers are the difference between the actual data from the table and the prediction that if you plugged 710 into this model, then it would give you a number that's 0.33 away from the actual value data point at 710. Okay, so that's what the residuals mean. So you want these, the closer these residuals are to the x-axis, the better your model. So just like when you do linear regression in the calculator, it gives you the values of your M and your B. Now, it looks linear, it looks great. You can get those residuals out of the way up here in the table if you click on the black dot with all the, or I don't know what color yours is, but if you click on that circle there, it just hides them. It doesn't delete them, it just hides them. Okay, now, we really think that it's linear, but let's check the other models as well. So let's put in the quadratic model. EX1 plus C. And I don't know why mine should have been set. I don't know if I have the same color. You can change the colors of your lines. No, I want to make it orange. Purple looks good. Okay, so there's a quadratic model for this one. For this limited amount of data, it's actually very close to the linear model. But if we compare the residuals here, they're pretty comparable to the linear one. But if you look at your parameters there, look at the value of A. It's in scientific notation with a 10 to the negative 7th. So that's a super, super tiny number for that coefficient on the quadratic. It's because it's really that you have to stretch this quadratic function out so much to make that fit this data. So a quadratic model, not really the best fit there. I don't want to delete that because I want to save that for more data. So I'm not going to delete it. I'm just going to click the little colored circle beside it, and I'm just going to hide it because I don't want to see it right now. And I don't want to see the residuals either. So I'm going to go up to the table and make those residuals go away. All right, really quickly, let's check the exponential one as well. Exponential is A times B to the x sub 1. Now, on the exponential, you want to click, once you get that in there, a thing pops up that says log mode. You want to click that. Okay, you do want to click that because if it's not clicked, it gives you R squared. If you click it, it gives you an R value. It gives you an R value. So we can compare R value to R value. The linear was 0.869. This one is 0.875. So technically, the exponential model here is the better model because it has an R value that is closer to 1. If we look at those residuals, we have a lot more that are a lot closer to the x-axis than we did with the linear model. And if you don't remember, just go back up here, make your linear residuals show back up. And you can see, for me, the black ones are the linear. So when I look at them, I have several more that are a little bit further away. The purple ones are my exponential residuals. They are seemingly closer to the x-axis for more of the points than the linear. So exponential is actually the better model here. So we can write down our, we'll say that this one's exponential. R equals negative 0.875. And our model is y equals 4.562 times 0.998 to the x. Okay, I was just copying those numbers from what Desmos gave me there. Okay, so a little bit of a crash course in it today. We will expand